Welcome to Easy Math TV. This is another video in our series on descriptive statistics and discovering patterns in data and patterns in populations. And this is going to be the first of two-parter. In this one, we're going to create something called Pascal's triangle in Excel. And these are going to give us what are called binomial coefficients, which are involved in um, something called a Bernoulli trial. So that'll all get explained later, but basically this is Pascal's triangle. So this is what you need to do. In Excel, you're going to need to kind of distribute. So like let's look at um, the top column or the top row, the top two rows. So the top numbers that you see here highlighted in green start with 0, and we're going to go all the way out to 15. I mean, we could go farther. You could go as far as you want, but I think 15 is a good ending point because you're not going to see many um, questions or problem sets that are going to ask you to go beyond n equals 15 trials. So that's the number of trials that we're going to be um, that we're going to repeat over and over and over again. So you're basically taking something that has a certain probability of occurring, and you're going to repeatedly try over and over and over to get success. And we're interested in the number of successes. So that's going to go in column A. In column A, we have the number of successes, which are, these are our X's, okay? And that's why I put them in the column, because we usually put our individual outcomes in a column, and that's how we're doing it here. So across the top is, these are our N's, so that's basically dictating like just how many possible values of X there could possibly be. And in column A, you see our X's. So X is going to go from 0 all the way down to 15 in this case. All right. So 0 to 15 across the top, 0 to 15 down. All right. The other thing that you need to just type in, and I've actually colored them in blue so that we can actually see um, where our starting point and ending point is for each column. So for example, if I look at just the number 8 here in column J, underneath the number 8, we have our possible outcomes are going to be X equals 0 down to X equals 8. So if you want, if we want that first column to always be visible and this top row to always be visible no matter where we go, we can click on, in this case, it would be cell B3. We can click on that cell and we can go to view, and there's this thing called freeze panes. We can actually freeze the um, the first column and the top two rows so that no matter how we scroll across or how we scroll down, we will always see the the value of n, and we will always see the value of x appearing. So n is at the top, x is to the left. Okay. The other thing we need to do is put ones. So let's just, these are just numbers we're going to type in. So this is just going to get us started with our Pascal's triangle. So starting with cell B3, type in a 1, and that number is going to get copied all the way across row 3. So you can actually see there's the numbers going straight across 1, 1, 1, all the way across to where n equals 15. That's column Q. So column Q is the end of our table. But ones go all the way across. And then the other place where we need to put ones is along this diagonal that you see here. So it literally is going down like a ladder or steps. Like think of these as steps going down. So you'll need a 1 in cell C4, a 1 in cell D5. Notice it just keeps going across 1, down 1 each time. And that will go all the way down to the last one that you type in should be in cell Q18. And the reason it's cell Q18 is because we already used the top 2 rows for something else. So it goes all the way down to Q18. All right. So that's just our setup. Those are not calculations. You just type in the number 1 that many times. You can hit Control or Command C and copy and paste. Just copy and paste all the way down that diagonal. All right. Okay, so we're going to work from left to right, and we're going to basically fill in everything that is in between those values. So there won't be anything down here below any of those diagonals, okay? The diagonals are where the numbers stop. So let's start with cell D4 here, and we're going to type equals. And what we're going to do is we're going to add 2 numbers to the left and above, like the number that's just to the left of it and the number that's just above that number. So we're going to start with C3 and we're going to add to that C4. So again, it's the number directly to the left plus the number directly above that one equals C3 plus C4. And we're not using a fixed reference because I really don't feel like typing in that formula umpteenth times. So like we're literally just going to fill across all the way to column Q. All right, now go back. The next empty space is down here in E5, and we're basically going to take the same idea. So we're gonna add the number to the left of this block and the number directly above that. So it's going to be D4 plus D5 equals D4 plus D5. Okay, hit enter and then go back to that cell and we're just going to drag that across. So I think at this point that we can actually do a fill down as well. So if I go to this one in cell F5, notice that's equal to E4 plus E5. What would happen if I hit on that anchor and fill down to here? That will do the same thing. So that adds E5 plus E6, which is good because that's what we want. So at this point, we could literally just fill in all of our missing cells by doing fill down. And this is going to give us the first essentially 15 rows of Pascal's triangle without doing any work ourselves. We don't have to do any of the work. We can get Excel to do all of it. And these are the number of ways that each of these outcomes can happen. Okay. And notice as I'm going, these numbers are getting pretty large, because you have a lot more attempts. So when you're flipping a coin or when you are selecting a yes or a no out of a box, and you're doing that 15 times, the possibility of getting, so let's just click on a random, here, we'll go to this one. So in column P, we have at that point, n is equal to, so let's go to insert, and I'm just going to put a comment in here. I'm just going to type what I'm about to say. So in column P, we have P2 is n equals 14. Okay, so that is the number of trials. And then to the left, let's look at A10. So A10 is x equals 7. And that means the number of successes is 7. So 7 out of 14, right in the middle there, right? 7 out of 14 successes. So what does the number in P10 tell us? 3,432. This is the number of ways that we can achieve 7 successes out of 14 attempts. The number of different ways that that can be arranged. So so if this is free throws and you have a basketball player that made 7 out of their 14 free throws, um, it didn't necessarily have to be the first 7 free throws, right? It could have been any of the 7 that are distributed among those 14. So there's literally 3,432 ways that you can actually distribute those 7 free throws that were made out of the 14 attempts. And it may seem like a lot, but that's the case. So these are called binomial coefficients, and we are just we'll save this table for the future. We're going to be just copying and pasting from here when we're studying something called the binomial distribution, and we're dealing with Bernoulli trials. Bernoulli trial is just named after a statistician by the name of Bernoulli. Um, but we'll call them binomial trials because they have two possible outcomes: success versus failure. um, and there's a special distribution concerning that, so we're going to talk about that going into the next unit of study. And I hope you're enjoying these videos. Please like, subscribe, comment down below, and definitely watch the next one, because we're going to be using these numbers to find probability distributions and study the something called the binomial distribution. Thank you, and I'll see you in the next video.